Welcome to my mathematics class, class 6, semester 2, fractions. Today we will know more about equivalent fractions. Say 1 by 2 is equal to 2 by 4 is equal to 3 by 6 is equal to 10 by 20, etc. These are all equivalent fractions. They represent the same fraction of a whole. They represent the same fraction of a whole. For example, I will show pictorially. Let us consider a rectangle. Make it half and shade one half. So the fraction of shaded portion is 1 by 2, because the total number of equal parts are 2 and the shaded portion is 1 part. Therefore, this is 1 by 2. And 2 by 4 is an equivalent fraction. We will see how make the same figure into 4 equal parts. Now the shaded portion is 2 equivalent fractions, 2 equivalent parts. Therefore, the fraction of the shaded portion can be written as total number of equal parts is written in the denominator, and the shaded portion 1 by 2. The number of parts of the shaded portion 1 by 2, that is written as numerator. Therefore, this represents, the shaded portion represents 2 by 4 here. Now, previously the shaded portion was represented by 1 by 2. Similarly, if we make 3 by 6, 3 parts, if we make it as 3 parts and the whole as 6 parts, 6 parts, we have to do 6 like this. Now the rectangle is made into 6 equal parts and the shaded portion is 3 equivalent parts. Therefore, the fraction of the shaded portion can be written as number of total parts and equal number of shaded portion. The shaded portion is 3 parts and the total parts are 6. Similarly, if we make it like this again, now total parts are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. And the number of parts shaded are 6. 1, 2, 3, 4, 5, 6. So 6 by 12. The same portion is differently represented as 1 by 2, 2 by 4, 3 by 6, 6 by 12, etc. Similarly, we can write it as a 10 by 20 also. If we divide the whole part into 20 and take 10 parts, it will be 10 by 20. So to make this as 10 by 20, we have to do like this. The same portion, that is of 20. 1, 2, 1, 2, 3, 4, 5. So like this is the shaded portion. So now the total number of equal parts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Therefore, total number of equal parts 20. Number of shaded parts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Therefore, the shaded portion represents 10 by 20. So all these fractions represent the same portion of a rectangle, half portion of the rectangle. So these are known as equivalent fractions. So the equivalent fractions represent the same part of a whole. Now 1 by 2 is equal to 2 by 4. 1 by 2 and 2 by 4 are equivalent. That is 1 into 2 by 2 into 2. 2 can be written as 1 into 2 and 4 can be written as 2 into 2. So this half, this fraction is multiplied by 2 both on the numerator and the denominator. Then we get 2 by 4. 1 into 2, 2, 2 into 2, 4. So if we multiply both denominator and the numerator of a fraction by the same number, we get an equivalent fraction. For example, consider 1 by 3. Write an equivalent fraction of 1 by 3. To get an equivalent fraction, we have to multiply both the numerator and the denominator by the same number. Either 2, 3 or any number. But we have to multiply both the numerator and the denominator. So 1 is multiplied by 2 and 3 is also multiplied by 2. We get 1 into 2, 2, 3 into 2, 6. Therefore 1 by 3 and 2 by 6 are equivalent fractions. Similarly, we can multiply both the numerator and denominator of the same fraction by 3, same number. 1 into 3 by 3 into 3. That is equal to 3 by 9. So 3 by 9 is also an equivalent fraction. So 1 by 2, 2 by 4 are equivalent fractions. 1 by 3 and 2 by 6 and 3 by 9 are equivalent fractions. Thus, we get any number of equivalent fractions by multiplying the numerator and the denominator of a fraction by the same number. Similarly, let us suppose that consider two equivalent fractions, 4 by 8 and some 16 by 32. These two are equivalent fractions. Let us verify whether they are equivalent or not. Now suppose 4 can be written as 4 by 8 and 4 can be written as 2 into 2 and 8 can be written as 4 into 2. Therefore we get 2 and 2 gets cancelled. Again 2 can be written as 2 into 1 by 4 can be written as 2 into 2. Again 2 and 2 gets cancelled, therefore 1 by 2. Or we can divide at the same time 4 by 8. We can written it as 4 into 4 and this as 4 into 2. 4 twos or 4 into 1. 4 into 1 and this is 4 into 2. So 4 and 4 gets cancelled. Therefore this is equal to 1 by 2. Directly if we write like this 4 into 1 and divided by 4 into 2, we can get it in one step. Or if we write like this, we will get in 2 steps. So 4 by 8 is equal to 1 by 2. Now come to this fraction 16 by 32. Divide into fractions, the factors. 4 into 4. 16 can be written as 4 into 4. Divided by 32 can be written as 8 into 4. 8 into 4. So 4 and 4 gets cancelled. Again 4 into 1. This 4 can be written as 4 into 1 divided by 8 can be written as 4 into 2. So here 4 and 4 gets cancelled, we get 1 by 2. Therefore 4 by 8 is 1 by 2 and 16 by 32 is also equal to 1 by 2. This is called the simplest form of this fraction and this is the simplest fraction of this fraction. Both are equal. Therefore 4 by 8 and 16 by 32 are equivalent fractions. Thus we can get the equivalent fraction. We can verify whether the given two fractions are equivalent or not. We have to divide or we have to write into factors. We have to write both the numerator and the denominator into factors and have to simplify. Or in other way, if we divide both the numerator and the denominator by the same number, 4 divided by 4, or let us take 2 as it is equal to the numerator, you will get confused. Therefore 4 divided by 2 by 8 divided by 2. Whatever number you take, you have to divide the numerator and denominator by the same number. We have to divide the numerator and denominator by the same number. So 4 divided by 2 is equal to 2 and 8 divided by 2 is equal to 4. So 4 by 8 and 2 by 4 are equivalent, because 4 by 8 is simplified like this, and again still it can be divided by 2 and 4 can be divided by 2. That is equal to 2 divided by 2, 1. 4 divided by 2, 2. Therefore 4 by 8 is equal to 1 by 2. 4 by 8 is equivalent to 2 by 4 and 1 by 2. Or 4 by 8, 2 by 4, 1 by 2 are equivalent fractions. And 16 by 32 is also an equivalent fraction. Let us say 16 by 8, 32. This can be written as 4 into 4, 4 fours. 32 can be written as 8 into, in divisions. We will write it as 16 can be written as 16 divided by 4. We will divide the numerator and denominator by the same number. This is divided by 4 and this is also divided by 4. Therefore, we will take 4. That is the common factor. We have to select a common factor of the numerator and the denominator. So 16 divided by 4 divided by 32 divided by 4. 16 divided by 4 is 4. 32 divided by 4 is 4 8s are 32. Therefore 32 divided by 4 is 8. So 4 by 8 is equivalent to 16 by 32. Again, we can divide it by 4. 4 divided by 4 and 8 divided by 4. Both the numerator and the denominator are divided by the same number. As they are divisible by 4, we selected 4. If both are not divisible by 4, we cannot select. For example, 4 by 8, both are not divided by 3. Therefore, we cannot divide by write it as 4 divided by 3 and 8 divided by 3. The number we select must be a common factor of the numerator and the denominator. So 4 divided by 4 is equal to 1 and 8 divided by 4 is 2. So 16 by 32 and 1 by 2 are equivalent fractions. Here 4 by 8, 16 by 32 are equivalent fractions. Therefore 4 by 8, 16 by 32, 2 by 4, 1 by 2 are all equivalent fractions. Among all these equivalent fractions, 1 by 2 is the simplest form of the fraction, simplest form of the equivalent fractions. Because we cannot simplify still, we cannot divide both the numerator and denominator by the same number. Then such fraction is called simplest form of the fractions. Now we will know an interesting fact. Now we will consider a table. I will write a table, a equivalent equivalent fractions, first column, product of numerator of the first fraction and the denominator of second fraction. Next, product of denominator of the first or numerator of the second. We will write that first, numerator first. Numerator of the second fraction and denominator of the first fraction. Next, inference. Let us take some equivalent fractions, 1 by 2 and 2 by 4. These are the equivalent fractions, we know. And 3 by 4, 6 by 8. These are equivalent fractions. Next, 1 by 3 and 2 by 6 are equivalent fractions. Now we take the product of numerator of the first fraction and the denominator of the second fraction. See, numerator of the first fraction 1, denominator of the second fraction 4, 1 into 4. And here 1 into 4 is equal to 4. Here product of the numerator of the second 2 and the denominator of the first 2. 2 into 2 is equal to 4. So product of the numerator of the first fraction and the denominator of the second fraction. Numerator of the first fraction and the denominator of the second fraction. 1 into 4 is equal to 4. Next, product of numerator of the second fraction is 2. And the denominator of the first fraction is 2. Therefore, product 2 into 2, 4. So, what is the inference? The both are equal. The value in the column 1 and the value in the column 2 are equal. Column 1 is equal to column 2. 1 is equal to 2. That is the value in the column 1, second column is equal to second column. Both are equal. So, similarly, these two are equivalent fractions. Now we will write product of the numerator of the first fraction and the denominator of the second fraction, that is 3 into 8. 3 8s are 24. Next, product of the numerator of the second 6 and the denominator of the first fraction. 6 fours are 24. Therefore, they are equal. Next, product of the first numerator of the first fraction and the denominator of the second. 1 into 6 is equal to 6. Next, product of the numerator of the second fraction and the denominator of the first. 2 into 3 is equal to 6. Both are equal. Now let us take two fractions which are not equal. 1 by 3 and 2 by 3. 2 by 3. These two are not equal or equivalent fractions. These two are not equivalent fractions. but the product of the numerator of the first fraction and the denominator of the second fraction 1 into 3 is equal to 3. And the product of the numerator of the second fraction and the denominator of the first fraction 2 into 3 is equal to 6. Are they equal? 3 and 6, are they equal? No, not equal. Not equal. The two products are not equal because these two are not equivalent fractions. Therefore, for non-equivalent fractions, these two products are not equal. For equivalent fractions, these products are equal. Thus, we can come to a conclusion that for one set of equivalent fractions, the product of numerator of the first fraction and the denominator of the second fraction is equal to the product of the numerator of the second fraction and the denominator of the first fraction. These two products are equal. So these products of numerator of the first and the denominator of the second and the product of the numerator of the second and the denominator of the first are called cross products. So for equivalent fractions, the cross products are equal. For non-equivalent fractions, these products are not equal. So this is a rule. We can check whether the two fractions are equal or not. We can use this rule. Good. Let us. Suppose there are two fractions. 1 by 3, 5 by 7. We have to know whether they are equivalent or not. Now we have to find out the fraction products. Product of the numerator of the first one, denominator of the second one, like this. If you mark like this, it is easy. 1 into 7. 1 into 7 is equal to 7. The other one is 5 into 3. 5 into 3 is equal to 50. So the products are not equal. Therefore, these two fractions are not equivalent fractions. Let us suppose another one, 4 by 5 and 8 by 10. 8 by 10. Products. Take this product and this product. 4 into 8. First product 4 into 8. 4 into 10. First product is 4 into 10, 40. And the second product 8 into 5 is equal to 40. The two products are equal. Therefore, the two fractions are equivalent fractions. This is cross product rule. So, if two factors are equivalent, the product of numerator of the first fraction and the denominator of the second fraction is equal to the product of the numerator of the second fraction and the denominator of the first fraction. So, using this rule, we can find out a missing number like this. Example 1. The following are two fractions, two equivalent fractions. These two are equivalent fractions. Then find out the missing number in the block. According to cross product rule, the product of the numerator of the first one and the denominator of the second fraction is equal to the product of the numerator of the second fraction and the denominator of the first fraction. So 1 into 16 cross product, this product is equal to this blank into 2. So 16 into blank into 2. 1 into 16, 16. 16 can be written as 8 into 2. 8 into 2 is equal to this box into 2. So 2 gets cancelled, or by observation we can know 8 is equal to this box. That is the unknown number. The numerator of the second factor is 8. So the unknown number, numerator of the second factor is 8. Thus we can use this cross product rule to find the missing number in a fraction. So we will continue in the next class. Meanwhile, you go through this class once again and watch the next reel.